Zheng, École Polytechnique Fédérale de Lausanne, Switzerland.
So, ladies and gentlemen, the first time when I told my grandma I'm a traffic engineer, my grandma said, "Are you driving the delivery truck or you clean the traffic signals?" Actually, I did neither of them. By the way, both of them have better salary than what I do now. But so transportation congestion is a bad thing, right? We see it everywhere in our city, so that means that we're not doing a good job, and it's a very challenging problem. And where is this challenge from? So on the one hand, the traffic system itself is a system of systems where the dynamics is very complex and is difficult to model, where on the other side, it's a system full of crazy and normal individuals that make choices that can never be predicted. Speaking of crazy choice, this pink shirt from my girlfriend, but anyway. So yes, so how can we tackle this problem? Traditionally, we look at individual sections links, but now we're thinking, okay, let's do it from a big picture. Here, what we have is the famous gas law, right? Without knowing the individual particles in the system, we actually can know the status and the movement of the gas. So if we apply this to our traffic system, so we simply collect the number of vehicles inside of the network and the number of trips arrived inside of this network, and then we will have this really nice fundamental diagram here. And what is good about this fundamental diagram is that you can see there is a magic number, the KCRs, 40 vehicles per kilometer for the city of Zurich. If we can keep our traffic operate at that place, then we are doing good. And what can we do with this fundamental diagram? So I actually have a very colorful graph to show you. Actually, afterwards. Okay, anyway, so with this fundamental diagram, actually, we can, with some simple clustering system, we can know where the congestions are. So here, for example, the San Francisco network, we have 3 different regions, which means we have 3 congestion major pockets, and by different days, they are different. Here, what I show is that we cannot see here, is we apply the so-called boundary control. We only control 20% of the traffic signals at the boundary of the network, and what we say is, we found if the traffic state is on the other side of the fundamental diagram, then we apply our control. So we ask vehicles to wait longer, but they can travel faster inside. I don't have the time to show you the movie, but I can tell you that this side is about applying our control. The other side is the normal control that are applied in the existing cities. And I can tell you we're doing better. Otherwise, I would not be standing here. Thank you very much.